In this video, we're going to conclude our discussions of the specific defense mechanisms looking at B cells and the humoral immune response. Now, the humoral immune response is a third-line defense. It is a specific immune response, and it is going to be a response that uses antibodies. Therefore, we say it's antibody-mediated response. And because it is going to use the antibodies, then that means it's going to be elicited through those B cells because it is our B lymphocytes which produce antibodies. Now, the humoral response is considered an indirect response because it's not a cell-to-cell interaction. Rather, it is the antibodies that are going to be doing that immune response against the antigens. Now let's do a little review on the B lymphocytes. Now, as we discussed with the T lymphocytes, B lymphocytes also have to go through a maturing process. So they do this in the bone marrow. So they get into the bone marrow and there's sites which contain stromal cells, and those stromal cells are going to provide those chemical signals, etc., that are going to initiate B cell development and ensure that only the proper B cells are going to maturity. Once that B cell has matured, they will leave that bone marrow, they migrate toward other lymphatic tissues, and generally speaking, it's lymphatic tissues that do not have T cells. If for some reason they're in a lymphatic tissue that has both T and B cells, you'll see that those two populations of cells are actually segregated as well. Now, as mentioned in a previous video, B often gets referred to as bone for the bone marrow, but actually it was from the term bursa because it was first discovered in the avian or the chickens in the tissue that they have, which is known as the bursa of Fabricius. Now, humans don't have a bursa, and so for them the process, as mentioned just a moment ago, occurs in the bone marrow. Now, if you look at our B cell picture up here, you'll see that the cell has receptors on the outside, and it is referred to as the BCR for the B cell receptors, and as we'll see, this is actually going to be antibody in nature. Now, as with the T cells, there is a specific video out there for B cell activation, and there's a whole page in your textbook that talks about B cell activation because it is quite specific in the steps. So do watch that, and when you're watching that, let me point out a couple of things that you need to be paying close attention to. First, that the B lymphocytes, they are going to be activated by our T helper cells. So make sure that you're paying close attention to the role that T helper cells play in that activation process. In particular, look for what those cytokines that are getting released. What's the chemical agents that are helping to activate the B cells? Also, pay attention to once those B cells are activated, how that they divide into two populations of cells. One is called the plasma cells, and the plasma cells are important because those are the ones that are actively engaged in defending the body against that foreign invader, because those are going to be the ones that are actively secreting antibodies. But they're also, once activated, they're going to produce a subset of cells known as memory cells. And those memory cells we're going to talk about here in a little bit because those are going to be the ones that help us elicit stronger responses each and every time we are exposed to an antigen. So, as this is known as the antibody-mediated response, let's look a little bit about antibodies. So what are antibodies? Antibodies are also known as immunoglobulins. That term comes from the immuno, meaning that it is an immune response or immune part or function, and then a globulin, of course, is meaning that it is proteins. So antibodies are large glycoprotein molecules that are going to be used in an immune response. We're also going to find that antibodies are going to be secreted by the B cells, and in some cases they're found on the surface of the B cells. So we're going to look at both of those. When you talk about the antibody, let's look at its basic structure. It's usually drawn in a Y-shaped structure because it has two components. The first component up here at what appears to be the top portion, and that's the part that is actually going to be the most active portion. This is the variable region, and the variable region is that part that gives the antibody specificity, because up here in this little fork shapes, it has regions that are going to be specific for a particular antigen. So each antibody has its own specificity for a particular antigen, and that is here at this variable region here in the pockets at the top. Now, all the antibodies will have what's known as a constant region, and then just as its name infers, it's going to be constant amongst all the different types of antibodies, and therefore they're going to help in specific roles with our antibody response. So again, they're called immunoglobulins when they're in the B cell or attached to the B cell, and then when they get secreted, we refer to them as antibodies. So let's look at our 5 classes of antibodies. So IgM antibody, that is going to be the first antibody that's produced in that antibody mediated response. And the IgMs are going to be what help activate complement. They're going to be involved in the processes of agglutination and neutralization. And we're going to look at the functions here in just a moment. The second antibody is the IgG antibody, and it is going to be the one that has the most common or is the largest percentage of antibodies, and it is going to help with attacking microbes and toxins directly. And one thing to remember about IgG antibodies is it's the only one to be able to cross back and forth from the placenta to help provide immunity to the fetus as it's developing. The IgA antibody is a dimer, and so as you can see here, it's got a 2-part structure. 2 of those Y-shaped antibodies are linked together, and the IgA is going to be one that is going to be found in secretion, bodily secretions. Most commonly that you would consider would be the breast milk and the passing of an antibody from a mother to a child. IgE antibodies is another one of our monomers, meaning it's just got one of the Y-shaped antibodies to it, and it's going to be found in the blood but not in a large quantity, and part of that is because the IgEs are the ones that can bind to mast cells or to the basophils and cause those cells to release histamine, and as you know, histamine can cause us to have a major allergic response. And then the last one is the IgD. The IgD antibodies are found on the surface of the B cells. So those are our 5 classes of antibodies. You should be able to identify their functions and what they look like, either for multiple choice or for matching. Now, there's a lot of functions of antibodies, but we're going to look at the 4 main ones. The last one on the list is that it's going to activate complement. We've already talked about complement in previous videos, but do recognize that the antibodies can help to activate that system and help us to defend against antigens through complement. The other ways that antibodies work are through what we call opsonization, and in the case of opsonization, the antibody is going to bind to the antigen, and then because it has that constant region on an antibody, it then allows a macrophage to come up to it, and when it sees that constant region, it goes, oh, this is an antibody. That means whatever it's attached to must be foreign, and we need to help clear that process. So notice here you see that you got the macrophage and it's binding to the constant region of that antibody, and it's helping that macrophage to identify and then to go through that whole process of engulfing the antigen and destroying it. Antibodies are also helping in what's known as agglutination, and just like the name implies, it's going to agglutinate and cause something to stick together. So here, as you can see in the picture, agglutination is occurring. So the antibody is binding to the antigen and it's binding to multiple antigens, and it's going to take something that might be very small and tiny and be able to move through the bodily fluids or into tissues and stuff, and it's going to agglutinate it, making it stick together. So now it's large enough that it can fall out of solutions or be large enough to be seen by our macrophages and other cells that are used to help rid the body of that particular foreign antigen. The last function for antibodies that we're going to discuss is neutralization, and as you may recall from our last unit where we were talking about how bacteria produce toxins, and the bacteria themselves, they have to be able to establish themselves in the host. So in neutralization, the antibodies are going to bind to that antigen on those sites that it uses to bind to host cells. So if it can block that bacteria, if it can block that toxin from binding to a host cell, it's going to neutralize out those effects. So again, just 3 of the functions of how we use antibodies to help clear foreign antigens from our system. Now, as you may recall, mentioned in the B cells when we were doing that overview, that once a B cell becomes activated, that it produces two types of cells. One is a plasma cell, in which it's secreting those antibodies to carry out those functions we just talked about. The other is that it will go and put some of its active cells in a dormant state that we call memory cells. And those memory cells will then go back to the immunological tissues, and they're going to stay in a dormant state for that first round of mechanisms, but then in every subsequent response, they will come out and they will help us to elicit that immune response, in particular the antibody response, at a much greater pace. So let's talk a little bit about immunological memory. Memory, as I just said, that's what's going to allow us each and every time we're exposed to an antigen to respond faster and faster to that antigen, so that ultimately we are able to defeat it before it's able to make us sick or ill. Now, because we have that memory, we refer to our response rates into two. It's either a primary response, and that's the very first time we come encounter with an antigen, or we have secondary responses. So the very first time we come in to contact with a particular antigen, if it makes it past that first line and that second line of defense, and it makes it to the third line of defense, then it's got to go through the process of we have to activate those T cells and activate those B cells. And while we're in that process of activating T cells and B cells for the first time, that's a slow process for us. And that's when we're going through, if you recall from that past Unit 4, we talked about the signs of infection and how long it takes us from the time of entering to start showing signs of infection to the process of healing. Normally that can take us a while in that first line of defense before we are able to activate the T cells, which then activate the B cells and then produce the antibodies. That takes a long time to get us there. However, because of those memory cells that we make after the T cells and B cells have been activated, and that send a good bit of their populations to the site of infection to fight off the current antigen, they both will send some away for those memory cells. So that means that when the second time we come in contact with that antigen, we've got those memory cells. So when we go to start to elicit a response, we already have some cells that are active but dormant. And because of that, those memory B cells, they can change into plasma cells almost immediately, and therefore it greatly reduces the time needed to start that antibody production. And then the third time we are exposed to that antigen, guess what? That time to activate B cells and produce antibodies is even less. So the memory that we're forming with each and every time we're exposed to an antigen means that we are being able to decrease the time from that antigen entering the body to the time for which we're able to elicit a major response. So it's very important for us to have that memory cell production. So when we produce antibodies, that helps us in eliciting an immune response. But let's talk about the different types of immunity that we have due to the antibody production. First, we say immunity can be acquired naturally or artificially. Now that term naturally means that we have, through our day-to-day interactions, have been exposed to the antigen through a natural process. Somebody sneezes, we breathe it in, and we have now that antigen inside. We get cut, we're outside in the dirt, and that bacterial gets in from a normal exposure. Artificially means that we're being exposed to an antigen through medical intervention. The other set of terms that you need to understand is how is the body eliciting an antibody production. If the body does it on its own, then we say it's an active response. So you get exposed to the antigen either naturally or artificially, but you as the host are making the antibodies themselves, then it says it's an active immune response. On the other hand, if you have gotten those antibodies injected or through medical intervention, you have had those antibodies put into the host response rather than the host making those, then we say it is passive. So that leads us to our various types of immunity once you know those four terms. So we can have a natural active, you can have natural passive, you can have artificial active and artificial passive. So let's talk a little bit about those. If it's a naturally acquired active immunity, then that means that this is the normal process for which you become ill and sick and recover. So again, you're playing with your best friend as a child, and that your friend is sick, and now you become sick because you have had a natural exposure to whatever was making your friend sick has now made you sick. And so now you are able to naturally being exposed to the antigen, and you're naturally producing antibodies. So it is naturally acquired active immunity. You're actively making the antibodies on your own from an antigen that you naturally acquired because of exposures. So exposure to someone who's sick, exposure to something that was in your environment like pollens, or might be even from digging around in the dirt and becoming exposed. So that is the way you have normally become sick, from just your natural day-to-day activities and from you yourself healing through the antibody production. On the other hand, you can have artificially acquired active immunity. So how does this differ from naturally acquired active immunity? It's because of how the antigen is entering the body. Over here, it's through a natural everyday process. From here, it's medically induced. And what do I mean by that? Vaccinations. So in this case, you are taking a piece of either dead bacteria, an inactive virus, a partially or attenuated living bacteria, whatever it is, and you are getting it injected in through a scheduled routine of injections so that your body is being exposed to small amounts under controlled conditions of a vaccination. So you are having the antigen because that piece of bacteria, that piece of virus is serving as the antigen. So you're having the antigen put into your body under artificial conditions, but controlled conditions, but your body is the one making the antibodies. You are eliciting your own immune response. You are helping it to develop that memory. And that's why we go by that schedule, and you'll have one vaccine, two vaccines, and oftentimes boosters. Okay, now what happens when you have naturally acquired passive immunity? Again, as we've talked about, naturally acquired means that this is a process that is going to occur under normal circumstances. But because it is passive immunity, it means that you're getting antibodies from another source in a natural way. How does that occur? Really, the only ways that occurs is from mother to child. It can be through those antibodies that are crossing the placenta, or it can be from the antibodies that are found in breast milk. But in both cases, the mother is passing the antibody to the child because the child has not had enough time yet to make those antibodies. And then the last one is that you're having artificially acquired passive immunity. And in this case, it means that you are having the antibody absolutely injected into you due to a biological process or due to an exposure that has caused the host not to be able to produce antibodies fast enough. So that'll occur in something like rabies or something that is very rapid, that you need to have those antibodies immediately to prevent illness from occurring. The last thing that we want to cover is what's that mean by hypersensitivity or allergic reactions. And in this case, this means that you're producing an antibody response. However, that response is greater than what is expected or needed to get rid of the antigen. So it actually causes harm to the person. So we say these are hypersensitivity, and there are 4 types based on their level of hypersensitivity. So the first one is type 1, which is the immediate reaction, and this is one when your body produces a huge amount of IgE all at once. And remember, IgE is going to bind to mast cells and base cells and cause a release of histamine. So you have a large amount of histamine produced, and that puts a person in an anaphylactic shock. Type 2 is an antibody-dependent cytotoxic allergic reaction, and this occurs during transfusions and where you have a mismatch of blood type, because this is an allergic reaction to cell surface antigens. And again, that's going to occur because you're having a mismatch of blood. Type 3 is an immune complex allergic reaction, and that is autoimmune responses. So like people who have Graves' disease or rheumatoid arthritis or things along those lines where you are building antibodies to self tissues. That's a type 3 response. And type 4 is a delayed reaction allergic response. And most people have some type of type 4. And this is going to be because of what you might call contact dermatitis. And so that might be because of something you touched causes a rash. And it might be a more immediate response, or it could be something like, man, I've been wearing the same foundation or makeup for 5 years, and just recently it's causing a breakout. That is possible as well, just because your body is building up so much of those memory cells that eventually it gets to a point that you have a rash or a contact dermatitis show. Okay, so those are our different types of hypersensitivity. Type 1 obviously is the most severe, to type 4 being the least severe. So that's going to conclude our sensitivities. It's going to conclude what we're discussing about specific immune responses. Go back and look again for that B cell activation video, and if you have any questions, don't hesitate to give me a call.